For this problem, if f of x is equal to x to the fourth minus 3x squared, it turns out the derivative is f prime of x is equal to 4x cubed minus 6x. This can be obtained using the formal definition of a derivative. In a little while, we'll talk about how to compute this derivative more efficiently. For now, we'll just take that as a given. Use this information to find the equation of the tangent line to y equals f of x at x equal 2, right transfer and slope-intercept form. And again, we do not need to confirm that f prime is correct to receive full credit. All right, so step one. First thing we do is let's figure out what f of 2 is. If I plug in 2 into the original equation, that gives me 2 to the fourth minus 3 times 2 squared. So 16 minus 3 times 4 is 12, and that's equal to 4. And so this is what we've known since algebra 1. If I plug 2 into this function, that gives me the y-coordinate. And so the graph passes through the point 2, 4. So it must pass through that point. Step 2. We now figure out the derivative at 2. Okay, now the derivative is given to us, and so I can just simply plug in 2 into that. So 4 times 2 to the third minus 6 times 2. And so that's going to be equal to 4 times 8 is 32, minus 6 times 2 is 12 is 20. And so I know that the slope of the tangent line is going to be equal to 20. All right, now given these two pieces of information, I can now find the equation of the tangent line. And we'll do this in two different ways. The technique that I learned when I was a kid is to use y minus y1 is equal to m times x minus x1. The slope is known to be 20. The x-coordinate is 2, and the y-coordinate is 4. And so we would have that y minus 4 is equal to 20x minus 40, so that y is equal to 20x minus 36. So that's one way to get the equation of the tangent line. Another way to do this is to directly set up y is equal to mx plus b, and we know that the m is 20. To find the b, I now plug in for x and y. So if I plug in for x and y, I have 4 is equal to 20 times 2 plus b, so that b is equal to negative 36. And therefore, the equation of the tangent line would therefore be 20x minus 36. Not surprisingly, the same thing that I had before. Okay, so that is how to find the equation of the tangent line. I used the original function to figure out the y-coordinate. I used the derivative to figure out the slope of the tangent line, and then use my techniques from algebra 1 to find the equation of the line given those two pieces of information.